So here's the central question. Can we use pure reason as our guide to understanding existence itself? And look, this isn't just about finding one single answer. It's really about exploring a specific method of thinking, a rational framework for one of the deepest questions we could ever ask.
Okay, so first things first, we need to actually build that framework. We're going to start by laying out 3 core rules for our investigation. You can think of these as our foundational logical axioms. Here it is, our first and most fundamental principle, and it's presented as a self-evident starting point: absolute nothingness. Well, it can't do anything. I mean, by its very definition, it has no properties, no potential, no power. It just isn't there. A simpler way to say that is that every effect needs a cause. You know, if we look around and see that the universe and life had a beginning, then this rule suggests they have to have a source, a beginner or an actor to get the ball rolling. The whole idea is that you just can't get something from true absolute nothing.
On to our second rule. Now this one suggests that you can figure out the nature of a creator by looking at what it created. It's like if you find a beautifully crafted watch, you know the watchmaker was skilled and precise, right? The same logic is being applied here to the universe itself.
Now check this out. To really illustrate that point, the source gives us a concrete example from our own bodies. This number you see, 5 nanograms per milliliter, that is the incredibly precise amount of growth hormone in our blood. To put that into perspective for you, that's like 5 parts per billion. It's an almost unbelievably tiny amount. And this is what's so incredible. A tiny, tiny deviation from that number, we're talking parts per 100 million of a gram, leads to these drastic conditions like gigantism or dwarfism. The argument from the source is that this exquisite, razor-thin balance points to a quality in its source: meticulous, incredible precision.
And this is where the source material connects that scientific observation directly to a theological context. This verse is presented as a reflection of that exact same principle, the idea that the perfect measure we observe in nature is seen as evidence of a purposeful and incredibly meticulous creator.
Okay, let's get to our third and final rule: a lacker cannot give. It's a really simple concept, right? You can't give something you don't have. Someone without knowledge can't give you knowledge, and a process without foresight can't create systems that are built for the future.
And the development of our lungs is used as a perfect example of this. Think about it. A fetus is getting all its oxygen from its mother, so its lungs are totally dormant. And yet, they are perfectly formed, ready to go for that first breath the moment it's born. The argument here is that an unguided, unconscious process just wouldn't have the foresight to prepare for a future it can't even anticipate. All right, so we have our 3 rational rules. We've built our toolkit. Now let's do the fun part and put it to the test. We're going to apply this framework to 5 common arguments about where the universe came from.
So here's the first idea we're going to test: the claim that the universe just popped into existence from absolute nothing, with no cause whatsoever. Applying our very first rule, the source argues that this is a straight-up logical contradiction. If nothing could actually do something, like create, then it would have a property, right? The property of being able to create. And at that point, it wouldn't be nothing anymore. It would be a something.
And just like we saw before, the source anchors this rational argument in a theological question from the Quran. It's a challenge, really, asking the listener to consider 2 logical impossibilities: being created by nothing, or somehow creating yourself.
All right, let's look at argument number 2. This is the idea that the laws of physics themselves, things like gravity, were the actual creative force behind the whole universe.
So the rebuttal here makes a really crucial distinction between a description and an actor. A law of physics, like gravity, describes how things work, but it isn't the thing itself doing the work. The analogy here is just perfect. Saying the law of building built the house confuses the blueprint with the actual builder.
On to argument number 3. This one suggests that over billions and billions of years, just random, chaotic processes eventually, by pure chance, stumbled into the incredibly complex and fine-tuned order we see all around us in the cosmos.
And this is where rule number 3 comes right back into play. A lacker cannot give. By its very definition, chaos lacks order. So the argument is, how can it possibly give order? It's like expecting a pile of random letters to just spontaneously arrange themselves into a brilliant novel. It needs an external organizer.
Now, this next argument takes a different tack. It basically sidesteps the whole creation question by saying that the fundamental stuff of the universe, matter, energy, it's always been here. It's eternal, so it never needed a beginning in the first place.
The rebuttal here really hinges on what we mean by the word eternal. The source argues that something truly eternal, something without a beginning or an end, would have to be static, unchanging. But everything we observe about our universe shows it is a dynamic system, defined by constant change. It's expanding, it's cooling down. Stars are being born and dying. So by this definition, it can't be eternal.
Finally, let's tackle a more modern argument, one that comes to us from physics. This is the idea that a quantum vacuum, which is often described as physical nothingness, can actually spontaneously create particles. But the source's rebuttal here is all about definitions. It argues that a quantum vacuum is not the same as the philosopher's idea of absolute nothingness. Not even close. It's a something. It's a sea of fluctuating energy, it has properties, and it operates according to very specific physical laws. Calling it nothing is really just mislabeling it. And this summary table just brings everything together beautifully. On the left, you've got the underlying assumptions of the arguments we just tested, at least as the source characterizes them. And on the right, you see the rational rules from the framework we built. It's really a contrast between two fundamentally different ways of thinking about cause and effect.
And that brings us to our final thought for today. It's a provocative question that the source material leaves us with. If we rely on principles like cause and effect for pretty much everything else in our lives, from science to just getting through the day, what does it mean if we decide to throw them out the window when we're facing the biggest question of all?